This video is going to go off of what we did in class today, which is graphing quadratic equations in factor form. If you're watching this video earlier, it might not be as clear, but as I would encourage you to go back over your notes after we do the activity in class, because we are going to pre-learn this section a little bit and then kind of bring it all together with this video. So your objectives is that you can graph a quadratic equation from factor form. I can graph a quadratic equation from standard form, and then you're going to know all the terminology of the graph of the quadratic equation. So here's some important vocab words, and I strongly encourage you to pause the video right now, write all this down with the pictures, and then listen to me on the video. So let's go through the vocab. So we're working with intercept, or we're more often going to call it factor form. Factor form is this right here. We have three variables in here besides x and y, which is in any standard equation that we need to graph. We have a. A is a scale factor, so in class we learned what a did. It made it open up or down, or can also change the width. It can make it skinny or narrow, or it can make it wide. And then we have p and q, which we learned in class that p and q are the x-intercept, zero, solutions, or roots. They have many different names. So on here, these are P and Q. It doesn't matter which one's P and which one's Q, but there are always two of them. Sometimes P and Q can be the same, which we'll talk about in the last example. The properties of a quadratic is that there's a vertical line symmetry. Each parabola, remember, is what the graph is called, not parabola. It's cut in half by a vertical line of symmetry. And that is also a function because it passed the vertical line test. The vertex, each parabola has a vertex, which is the highest or lowest point on the parabola. So right here on my vertex, here it is a low point. When it opens up, it is going to be a low point, which makes it a minimum. A minimum is your lowest. However, when it opens up, it makes it a maximum. And it's also an important part with the parabola. Notice on this part, the parabola goes down, hits a vertex, it goes up. It's going up, hits a vertex, it's going down. So it's where the parabola changes directions. And lastly, the axis of symmetry is a line. It's this red line here, and then this one has the axis of symmetry, which I'll make in red too, best I can, that cuts the parabola in half. When we write the axis of symmetry, and I'm very strong on this, it is a line, the line x equals in whatever number the axis of symmetry is at. So it could be like x equals 5 or x equals -2. If you just put 5 or -2, I'll mark it wrong because it's x equals. Just like a vertex, it is a point. So you need your parentheses and your x and y coordinate. And then again, there are the four names for the x-intercepts, which we talked about in class. We have the solutions. Remember when we're trying to solve, when we set it equal to 0, our solutions are the x-intercepts. Again, they're x-intercepts because you cross the x-axis. They're also called zeros because it's where the function makes a 0. So these two go hand in hand. And then they're also called roots, which I'm not going to go into too detail where that name comes from. It is more of like an Algebra 2 college algebra topic. All right, so here's our first example that we're going to graph and fill out the information below. So first off, you need to tell whether or not it opens up or down. So here we look at A, the number out front. It is positive, so I know my parabola is going to open up. So when I'm done with my graph, it should open up. Just kind of a way to check yourself to make sure you're doing it right. So then we have our zeros on here. Our zeros are solutions, so what are going to make each one of these 0? Well, that is 3. And -1. Over here, notice we have a table, so we're going to fill out the table. So 1, 0 is at 3, so we have the point here, so that's 3, 0. And then we have -1, 0. Okay. Well, since parabolas have symmetry, I can find my axes of symmetry, which is going to be in between these 2 points, so I find the middle, which is right here. Well, that happens to be at 1, and don't just write 1, it's x equals 1. Well, the vertex is always on the axis of symmetry. So I know the x-coordinate of my vertex is 1. So to get the y-coordinate, we're going to use our equation to figure it out. So I'm going to plug it in. I go 2 times 1 minus 3 and 1 plus 1. And I get y equals 2 times negative 2 times 2. I would not encourage you to do this in your head. Write it out. Well, 2 times negative 2 times 2 is negative 8. So my vertex happens at 1, negative 8. Oh, I'm not quite sure what happened there. Undo that. Alright, so I plot 1, negative 8, which is right here. Alright, so when you're, for our parabola, I'm going to require you to do 7 points, except in one case I'll only require you to do 5. So you need to look at what x values we have and did. So we have done x equals 3, we've done x equals 1, and x equals negative 1. I'm going to look for ones that are in between. So I notice right here I don't have anything along x equals 2. So I'm going to plug in 2. So I have y equals 2 times 2 minus 3, 2 plus 1. I get negative 1, 2, 3. This gives me negative 6. So I plot 2, negative 6. Now I have this point, and remember their symmetries are reflected over, and I get where x is 0. So I have negative 1, 0, 1, 2, 3. So I need to go on the outside. So I either could do 4 or negative 2. You don't want to go too far away, otherwise you're going to get points way up here. So I'm going to do 4. I like to stay positive. They're easier numbers to work with. But feel free, you could have did negative 2 and you're going to get the same answer because of the symmetry. So I get 2, 1, 5. I get 4, 10. So I plot 4, 10, and then I can reflect it over. Last step is connect all your points. Your parabolas will probably look a lot better than this. It's really hard to draw on this board. And there you go. And now I can check myself that it opens up. Alright, so on this one, I decide whether it opens up or down. Well, we have a negative 2 out front, so it opens down. I can find my zeros. We have x and x minus 4. Well, what's going to make x 0? That is 0. And then we have 4 to make this 0. So I can plot those 2 points. And I can put them in my table. We have 0, 0. And we have the point 4, 0. Look for my middle. My middle happens to be at 2. My axis of symmetry is x equals 2. Again, make sure you have x equals. So then my vertex has to happen at 2, and then whatever it comes out to be. So I go negative 2 times 2, and 2 minus 4. I get negative 2 times 2 times negative 2 gives me a positive 8. So I plot the point 2, 8. That is my vertex, my highest point. Alright, so now again I look for missing x values. I have 0, I have 2, I have 4, I do not have 1. Or I could have did 3. So I go negative 2 times 1, and 1 minus 4. It's negative 2, 1, negative 3, gives me 6. I plot the point 1, 6, reflect it over, get my other point. Alright, so now I need to look. I have 1, 0, 1, 2, 3, 4. So I either could do 5 or negative 1. I'm going to do 5. I like to say positive. You could do negative 1 if you want to use negative values. So this is 1. It's kind of a shortcut. You can go negative 2 times 5 times 1 is negative 10. I have 5, negative 10. Right. And then I can connect my points. Make sure your top is curved. It's not like a V. It's not sharp. And again, yours is going to look a lot better. It's really hard to draw on this board. And again, I know I'm done because I have 1, 2, 3, 4, 5, 6, 7 points. All right, so what's different about C is this one is not factored. So the first thing I need to do is factor. To do that, notice the 7 is on the opposite side of the equal sign versus this x squared minus 6. So I need a minus 7 over. I'm going to do my work over here. Plus 6x minus 7 equals 0. Well, now I need a factor, which you should be excellent at this point after last chapter. Factors of negative 7 that add up to 6, well, that is 7 and negative 1. Well, my A is positive, so I know it's going to open up. My solutions are negative 7 and 1. So I can plot my points, put them on my chart, my table of values. All right, so I need to find my axis of symmetry. So I need to find the middle of negative 7 and 1. That is at negative 3. So I'm going to draw my dashed line so I know that is the middle of my parabola. So it's x equals negative 3. So now I can find my vertex. Pen stop working. So I have x equals negative 3. Plug in negative 3 into what I have factored. So I have negative 3 plus 7. Negative 3 minus 1. As a shortcut, I kind of like to write the numbers above it, and then I can just quickly multiply them. 4 times negative 4 is negative 16. Now in this one, this isn't going to fit on a 1-to-1 scale. I don't need to change the x-axis at all because I'm just going to use single values. But I do need to change the y-axis, so I just need to write, I'm going by 2s. If I go by 2s, I can fit negative 16. So I go by 2s. 2, 4, 6, 8, 10, 12, 14, and 16. All right, so now I need to look for values, and I try to go in between first. So I have 1. I do not have anything at 0. So I plug in 0. 0 plus 7. 0 minus 1. So I get 7 times negative 1 gives me negative 7. So going by 2s, 2, 4, 6, 7 would be right in between. I reflect it over. All right, and I can do my next one, which is negative 1. So go negative 1 plus 7. Again, I encourage you not to do this in your head. Write it out. That's where mistakes are made. Negative 2 and 6 gives me negative 12. All right. Negative 12 would be right there. All right, I have 7 points. So I can make my U. Put arrows at the end because our parabola does not stop. All right, so on D, it's very similar to the other one. It is not factored, and they're both on both sides. So I'm going to add 14 over. So I have 7x squared plus 21x plus 14. All right, so remembering your factoring, I try to pound it in your head. First thing you should look for is a GCF, and I notice all 3 have a GCF of 7. Or they're all divisible by 7. So I can pull out a 7 plus 3x plus 2. That 7 tells me this graph is going to be very skinny, or it's going to go very fast because it's going up by 7s, or has a scale factor of 7. All right, so this opens up because 7 is positive. I need a factor, and I still have 7 up front. I have x, that is 2, and x equal plus 1 gives me 3. So my solutions are negative 2 and negative 1. I go -2, 0, -1, 0. Plot those on here. All right, so I need for my axis of symmetry. And notice my axis of symmetry is actually in the middle of -1 and -2. It is going to be halfway. So I'm going to draw the best I can. It's really hard to do this on the board. You can do better on your paper. So I'm halfway. So my axis of symmetry is that x equals -1.5 or -1.5. If you want to use 1.5, go right ahead. If you're more comfortable with decimals, do that. So then my vertex is at -1.5. And then I need to figure out the rest. So plugging in, I get 7, -1.5 or -1.5 plus 2, -1.5 plus 1 gives me 1/2 times -1/2. All right, grab my calculator. 0.5 times -0.5 is -0.25, and then I need to take it times 7. -1.75. All right, so be right here. All right, so I need to plug in my next point, so I'm going to plug in 0. So I get 7 times 0 plus 2 and 0 plus 1, and I get 2, 1, 7, which gives me 14, which now I notice, oh, my scale is not big enough, and that's only the next point over, so I know I'm going to have to go one more. I'm going to plug in 1 because that's going to be my next value, and just kind of see what my scale needs to be. And I knew this one was going to go up fast because I had a big A. Well, now we're all the way up to 56. All right, so I'm going to erase this point right here. All right, so I need to go up by 56, and I only have 10 here. So I think we'll be okay if we might actually have to go up by 10s. So my scale is now by 10s, which makes my vertex really, really close to there. And then I'm going to go 0, 14, and 56. Should be right here. All right. There we go. All right, so on E, notice that E again is not factored, and I just want to point out one thing. I'm actually not going to go through this part, but I want to go through the factoring. Notice x squared is negative, and a lot of you might just stop and say, okay, I'm going to just try to factor if x squared is negative. This can be quite difficult. It is possible, but it kind of plays with your head. We always want the leading, the x squared, to be positive, so I'm going to divide by -1. I'm going to find a GCF of -1. So if I make it -1, then I get x squared minus 16. This right here is one of our special cases, so that factors into x minus 4, x plus 4, and -1. And then I'll know that it opens down, and then I have zeros of 4, -4. You're going to get an axis symmetry of 0 and vertex. If you want to do this problem, go through it. It'd be a good one to practice. I can check on your work tomorrow in class to make sure you did it right. But I'm not going to waste your time watching this video doing this one, where it's very similar. However, we're going to do F because this one is quite unique. So in here, I'm not factored, so I'm going to factor it. And notice when I factor it, factors of 9 that add up to -6 are x minus 3 and x minus 3. I know this is going to go up and up because we have a positive a, it's 1. The solutions, notice the solutions, they're the same. So I actually only have one solution or one x-intercept. When that happens, I'm no longer going to require 7 points. I'm only going to require 5 points. So I have 3, 0. Well, since I don't have 2 points to go in between, this is also my axis of symmetry. That is my middle. Let me draw that on there. Like so. Well, since that's my axis of symmetry, that makes this root, or this solution, my x-intercept. Or my vertex, sorry. So that is my vertex. So this is why you require, because normally we get 2 points from the roots and then 1 from the vertex. So I kind of take away 2 there. So we're only going to do 1. So I just need to find 2 other points. So I can go on one side of the line. Next x value over is 2. So I can plug in 2. So go 2 minus 3. 2 minus 3. If you want to write it as x plus 3 or x minus 3 squared and calculate in there, go right ahead. So that's -1 times -1 gives me 1. So we have 2, 1. Reflect it over. Do another x value. I could do 1 or 5. I'm going to do 1. So I go 1 minus 3. 1 minus 3. I get -2 times -2, which gives me a +4. Right? And then there's my points, my 5 points. All right, so just to review, remember all your graph terminology: axis symmetry, vertex, y-intercept, the name of the graph, the parabola, not parabola, the x-intercept, 0, solutions and roots. You're going to be quizzed on this and tested on that. The tips, to remember, you'll reflect half the parabola. You only have to do half and just reflect it over. Get everything to one side when you're solving. Factor completely. Don't forget your GCF will make your life easier. And use your common sense. When I say it opens up, your parabola should open up. If it looks off, you're more than likely that you did something wrong. Just go back and recalculate and make sure you're doing it right. Or call me over tomorrow and we'll figure it out. Reminder to do your reflection to get credit for watching this video.